This is an introduction to the Gink database system. Um, so why did I create this? I wanted a database system that's file-based and easy to use, you know, flexible, easy to sync, and most importantly, it's possible to keep the history, detail record of all the transactions and be able to jump back to snapshots and stuff like that. So basically this is something like Git, but for more complicated or even more common data structures. Gink directories are like Python dictionaries. So in this example, I'm just creating a database object for demo.db is the file name that the database is going to be in. I create a directory that's just named example, and then I can set some key is equal to some value there, and you can get it back out using the bracket notation that you can typically with other mapping things like dictionaries. In addition to having values which are just other strings, you can have directories point to other directories. Additionally, this is showing that you don't have to explicitly specify what database you're using. When you create a directory, it will just assume the last database that was opened. So um, there's a root directory that's always present. This is useful so that way you can, when you create directories or other data structures, you can get to them next time you open a database. So here again, it's a directory just like we've been talking about. So some key goes to some value, or you can link to a directory that you've created. In addition to simple string values, you can store more complex objects. Here I'm storing something that is a dictionary itself, so kind of like what you would see in a document store. You can also store tuples, which are essentially passed in as lists or Python tuples, as well as you know um, um, booleans, binary data, and none values. So in addition to this directory thing, which is a little bit like a Python dictionary, there's some other data structures which are present in Gink. One is called a box, which is like a directory, but there's no key, so it just holds one value. There's also a sequence data type that you can use as a queue. It's just like an ordered list, essentially. There's something called a key set, so you can, the same way you can use like a Python set. And there's something called an accumulator that you can use to keep track of numeric balances. So as previously mentioned, one of the goals is to keep track of a history of all transactions. So in so you can say show log, and it will show you what has happened. So in this case, the first transaction that happened was a sequence was created. Secondly, that sequence was put into the root directory. And thirdly, we appended to that sequence that foo bar value. So the show log here, it's passing in a format string because the full log shows the transaction IDs and stuff like that. So I'm just showing that it keeps track of the, timestamp as well as the user that created it or any other identifier that you want to identify yourself as. You have some control over the transactions, so you can say database.bundler and bundle a bunch of transactions together. Here I'm saying combining some operations together as the comment. You can also pass in to all of the modification operations except a comment as an argument. And that is one way of seeing, manually annotating what you're doing. So in addition to keeping a log of what transactions happened, you can look at the state of the database at times in the past. So in this example, you've set the key 1234 to some very important data and you accidentally overwrite it with something else that's not the very important data. You can go back and say, okay, well, give me the data as of a particular timestamp in the past, and it will tell you what it was at that time. Additionally, in addition to just being able to look at the state of the database at points in the past, you can reset to previous points in time. So here, again, it's setting it, the key 1234 to some very important data, then overwriting it with something else. When you say directory reset -1, that's just saying reset the most recent operation on that directory. So then it'll say very important data. Now, after that, I'm saying database reset -1. So it's resetting to what the database looked like before the previous operation. So it could reset over a reset. So even resets don't wipe out history. They're just literally setting it again to the previous value. So one of the nice things about having a file-based system is that it's pretty easy to write web backends. Here's a simple hit counter that's put together using the accumulator container. So I'm creating a accumulator, assigning it to the counter in root, and then every time there's a hit, it just gets that counter out, adds one to it, and then returns what the current value is. That's it for now. Next time we'll talk about synchronizing databases between servers, sharing databases with JavaScript, and other architecture and performance considerations. And that's all.